Hey, Chan Physics, just Mr. Block on Sunday night. Just trying to do a quick video on how to do some of the problems on the quiz. So if you're getting the quiz back and you're like, what did I do wrong? Hopefully you can be watching this, okay? So the first one, we just wanted you to find the total resistance. And so what we got here is a combination circuit. How do we know it's combination? Well, we got some in series and then we got something in parallel, right? And the first thing you need to do is whenever you see that is you got to go way across, away from the battery and work your way back. And the first thing you have to do is you have to start thinking about this problem in steps. A lot of us want to do it in one step. It's just like we want to do it fast, and it's not fast. It's a methodical, step-by-step process, okay? And so when I look at this, I go, these two are in series, and then this is in parallel with these two, but these two are in series. How do I know they're in series? Well, because they have the same current. Whatever comes into this right here goes through this one and then goes through this one. It's got to be the same current. So these have to be in series, and then once I combine these two, I can put these two in parallel. So it's a three-step process, and let's start by putting these two together. So what we got here is we've got a 9 ohm resistor and a 3 ohm resistor. And so I'm just going to do RS is equal to 9 plus 3 and equal to 12. All right. So what I tell my classes is that then once you've done one thing, you have to redraw. And so I've got a battery, and I've got this resistor here and this resistor here, and I just put those two together. So I redraw, and this is a 12, and this is a 6, and this is a 2, and this is a 3. Okay, and our battery's still 27, I believe. All right, so step one, put something together. Step two, right, redraw. So now I redraw and I look and I say, okay, well now if I go far away from the battery again, I've got a 12 and a 6, and these are definitely in parallel. So I'm going to start with step one again. But when I do parallel, I have to use the parallel equation. So 1 over RP is equal to 1 over 6 plus 1 over 12. Right? 1 over RP equals 2 over 12 plus 1 over 12, or 1 over RP is equal to 3 divided by 12. Okay, RP over 1, see I flipped them, is 12 divided by 3, or 4. Okay, so that was my step one. Step two, come back here, draw my battery again. I got a 3, I got a 2, and now I've got a 4. Okay, a 3, a 2, and a 4. All right. Now, if I gave you this problem, you'd say, oh, Mr. Block, this is real simple. It's a series problem. So I just go back and step one, RS is equal to 3 plus 2 plus 4, and that's equal to 9. And the answer was 9. Okay. So we have to be willing to do the work. We cannot just simply hope that we can just fast forward through a problem. This is how they do it at the University of Illinois in electrical engineering school. They do step by step by step. And if you think you're smarter than the number 2 electrical engineering school in the nation, then please, please, please come talk to me, because I want to make sure that you get into the right kind of school. But everybody else, in all of my classes, we just take our time. We do our work. We know that we have to do some work, and we take our time. If we want to keep going so fast, or if we want to fast forward through this, we're just going to get it wrong, okay? All right, the second problem asks us to both find the total resistance and the current in all the places. This is where either you know what you're doing or what you're not, or you don't. And so the first thing I want to talk to you guys about is you need to know what electricity is. Electricity is electrons moving around in current, all right? Current like water going through the pipes. The current is either going to go through this loop or it's going to go through the middle loop here. And you need to understand is that if an electron, which is current, comes to this back of the battery, it has to be at 0 volts. It has to be dead tired. And it's going to come across this battery and it's going to get electrified. It's going to get some energy. And by the time it gets back around, it has to lose all of that. Okay? So there's thousands, billions of electrons actually moving around this circuit, right? And so some of them are going to go this way, and some of them are going to go this way. Okay, and we're going to have to figure out just about how many are going this way and how many are going this way. All right. So the first thing we do is we look at the battery and say we're going to go as far away as we can. And we see that these two resistors are in series. They have the same current going through them. So we need to put those two together first. So we do step 1, Rs equals 2 plus 10 or equal to 12. All right. I redraw. So I've got this battery here. I didn't touch the 6 ohm resistor, so I'm going to leave that. And now I have a new 12 ohm resistor right there. All right, so that's 12. All right, that's step 2, redraw. Now, what I say is in these kind of problems is if you get to step 2 and you don't have a simple circuit, which is a battery and one resistor, then you have to start over again. Go to step 1. All right, so step 1 is, okay, I got to combine these two. Well, I see that they're in parallel. So I'm going to go 1 over Rp is equal to 1 over 6 plus 1 over 12. All right, and I keep moving down, so 1 over Rp is equal to 2 over 12 plus 1 over 12, or 1 over Rp is equal to 3 over 12. Okay, now that's great that we got there, but we don't want 1 over Rp, we want Rp, we want the parallel resistance. So we have to flip both of these fractions. We get 12 divided by 3, or 4. Right? So 4 is the total resistance. All right, well, I'm going to go back. I'm going to redraw. I got a 12 volt battery and I got a 4 ohm resistor. 12 volt battery and a 4 ohm resistor. All right, that's step 2. Now I have a simple circuit. Now I'm ready to go to the next step, which is step 3. I'm going to write down Ohm's law, V equals I times R. And I'm going to put 12 is equal to I times 4. This resistor right here, this resistor, not one of these ones, this one. Because what we're going to try to do is we're going to try to find the total current coming out of the battery. So all we do is divide by 4 on both sides. We get I is equal to 3. All right, I equals 3 is the total current. And what I tell my class is that we move down, and now we're going to move back up. So what are we going to do? We're going to put the current into our pictures. The current coming out of the battery is 3. Since this is an equivalent or circuit to this, the current coming out of here is 3. And since this is an equivalent circuit to this, the current coming out of this battery is 3. Now we're ready to put something into our boxes. Okay? So the first thing we need to do is follow our current. We know that once we get to right here, then the current has to split. If we had 3 Jolly Ranchers, and we said 3 are going to go this way, some of them are going to go this way, and some of them are going to go this way. And when they come back together, there'll be 3 again right here. So we know that in this problem, finding the total current, which is right here, and finding the total resistance, which is right there, all right, have given us just this little bit of information, 3. But they have not given us anything more because I don't know how much went through here, and I don't know how much is going to go through there. So I need to switch to voltage. I've done all this work to get to current. Now I have to switch to voltage. And so remember my rule. I'm a little electron right here. I'm tired. I gain 12 volts across this battery. I'm going to follow along this middle loop right here. If I gain 12 here, I have to lose 12 here to get back down to 0. If I gain 12 here, I have to lose 12 volts across the 6 ohm resistor. The voltage drop here has to be 12. Okay? So how does that help us? Well, hidden in these boxes is V equals I times R. And so 12 equals something times 6, or 2. All right? Now, once I get that, I've got the voltages. I've got a new clue, because now I know that 2 amps are going to go through here. 3 are here, 2 are going this way. So if 3 comes into this point and 2 go this way, there is only 1 left to go there. And once I know that, well, 1 comes here, it's going to be 1 here, it's going to be 1 here. And so the 1 and the 1 go right there, right? There's 1 amp going through here, and there's 1 amp going through here. Right? Now I'm ready to look at here. R equals I times, or R times I equals V. So 2 times 1 is 2, and 10 times 1 is 10. All right, now there is no meaning to this box right here on a combination circuit because we have 2 loops. So adding these up or trying to find some sort of pattern here is fruitless, right? Instead, what we need to do is check each loop. If we gain 12, we have to lose 12. If we gain 12 here, we have to lose 12. We've got the first loop, looks right? The second loop, which is the big outer loop. If we gain 12, we have to lose 12 between these two. We lose 2, and then we lose 10. That's 12 as well. And so now we know that we've done this correctly. We've lost 12 in both loops, and our problem is correct. All right. If you have any questions about the back side of the quiz, look at the key that's posted. These are all straightforward equations with the power and the Ohm's law equations. But we need to learn how to do these, and I will be talking to you guys more and more about getting this down. Bye-bye.